Hello and welcome to solving quadratic equations using factoring. In this video, I assume that you already know how to factor using these 5 factoring techniques. Factoring using the greatest common factor, factoring by grouping, factoring trinomials where the leading coefficient is 1, factoring trinomials where the leading coefficient is not 1, and finally factoring the difference of perfect squares. I have a quadratic equation 8x squared minus 6x equals 0. I know it's quadratic because it has the power of 2 above the variable, so it's not linear and we cannot simply get the x by itself. It is very important to note that to solve a quadratic equation using factoring, that equation must have a 0 on one of the sides of the equal sign. This equation satisfies that condition. It already is equal to 0, so we're ready to go ahead and solve using factoring. Well, since we're solving using factoring, it only makes sense to go ahead and factor. This is a binomial. I will be factoring using the greatest common factor, and that's this very first technique, GCF. I'm noticing that the 8 and the 6 have a 2 in common, so the first part of GCF is 2. And then 8 has 2 x's next to it, and the 6 has 1 x next to it, so they have 1 x in common, and that will join the 2. Now, inside of the parentheses, from the 8, because it's divided by 2, I have a 4, and I'll put it here. And from the 6, it's divided by 2, I will have a 3 left. Now, as for the x's, next to the 8, I used to have 2, 1 is left, and next to the 3, there will be no x's left, so it equals to 0. Now, to solve this, I will be taking each factor. I have two factors here. The 2x is my first factor, and 4x minus 3 is my second factor, and I will be setting each one individually equal to 0. So the first factor, 2x equals 0. To get x by itself, I simply divide both sides by 2, and my x is 0. And that is your first answer. The second factor is 4x minus 3, and I set that equal to 0. To get my x by itself here, I will first add the 3, which will leave me with 4x equals positive 3, and then I will divide both sides by 4. So my x is 3/4. Here are your two answers for this quadratic equation. Let's look at the next example. So here is another example of an equation. It's actually a cubic equation because it has the power of 3, but we will still be solving it using factoring. And the first thing I'm noticing here is that after the equal sign, you actually don't have a 0. You have these two terms. So I will first be taking each one of those terms, the negative 7x squared and the positive 63, and moving both of those to the left side of the equal sign so that on the right side I have a 0. Well, here we go. I still have my 5x cubed. I have minus 45x. Then I will be adding the 7x squared because it was subtracted here on this side. And finally, I will be subtracting the 63 because it was being added on the right side here. Now my equal sign, and after the equal sign, I will have nothing because both of the terms that were after the equal sign are now on the left. This equation here has 4 terms on the left. Whenever you have 4 terms, the technique that comes to mind is grouping. So that's my number 2, and I'm going to try to factor by grouping. So from the first group, I will be taking out a 5 and an x, which leaves me with x squared minus 9. And then from the second group, I will be taking out a 7, which leaves me with x squared minus 9 equals 0. I'm noticing that x squared minus 9 are the same, so I will repeat x squared minus 9 in the front, and then everything that's not matching, 5x plus 7, will be in the second set of parentheses, still equal to 0. Now here I would like to notice that one of the sets of parentheses, specifically the first one, still has the square, x squared, inside of it. And if that's the case, it's potentially factorable more. This here, x squared minus 9, will be factored using the difference of perfect squares. It factors to x minus 3 and x plus 3, and then you have your 5x plus 7 following. Now the idea is exactly the same as before. Once it's factored, you will take each and every one of the factors and set each equal to 0. So x minus 3 equals to 0. To solve, I'll add this 3. So x is positive 3. That's the first answer. Go back to my second factor, x plus 3 equals to 0. To solve that, I will subtract the 3 because it was plus 3 on the left. So x is negative 3. That's the second answer. And finally, 5x plus 7 equals 0. That's this third factor here. And to solve that, I will first subtract the 7. So 5x equals negative 7. And then I'll divide both sides by 5. So my third answer is negative 7 over 5. Let's go on to the next example. So here is question number 3. I have x squared plus x equals 2. Again, it's a quadratic equation because it has the x squared inside of it. So I will be trying to solve it using factoring. An important thing to keep in mind is to have a 0 on one of the sides, and I currently have a 2. So this 2 needs to be on the left side. It's a positive 2. So for me to move it, I will be subtracting it. Here is the new equation. X squared plus x minus 2 equals 0. Now this is a trinomial, and the leading coefficient, the number next to x squared, is 1. So this is the third technique of factoring trinomials where leading coefficient is equal to 1. To factor this, I will simply find two numbers that multiply to negative 2, and there's only two options, 1 times negative 2 or negative 1 times positive 2. And then I will check what these pairs will add to. So this first pair adds to negative 1, 1 plus negative 2, and the second pair here adds to positive 1, negative 1 plus 2. I want my pair to add to the number in the middle, which happens to also be 1. Remember, the leading coefficient was 1. This number is also 1. So the two numbers that add to 1 are negative 1 and 2. Here is the factored form. X minus 1, it's this negative 1, and x plus 2, that's this 2, equals 0. Same drill as before, we simply take each factor and set each equal to 0. X minus 1 equals 0, which means x is positive 1, because you take negative 1 and add. And then x plus 2 equals 0, which means x is negative 2, because you take this positive 2 and subtract. Let's look at example number 4. 2x squared minus 5x plus 3 equals to 0. It's a quadratic trinomial on the left, quadratic because it has the x squared, trinomial because it has 3 terms. So this will be this factor in the trinomial with the leading coefficient that's not 1. The leading coefficient here is a positive 2. This equation is set up for factoring because it is already equal to 0, so we don't need to make any moves before we start factoring, and let's go ahead and begin. So I will multiply 2 by 3 first, that's a 6. I'll break down the 6 into all possible pairs of numbers that multiply to 6. 2 times 3 is 6. Negative 2 times negative 3 is also 6. 1 times 6 is also 6, or negative 1 times negative 6 is also 6. Now I will be adding them. So the first pair will add to 5, 2 plus 3. The second pair will add to negative 5. The third pair will add to 7, and the last pair will add to negative 7. I, of course, want my pair to add to the number in the middle, which is negative 5, so the second one is my pair. Keep in mind that the leading coefficient here is not 1 like in my third example, so this pair is going to be used a little differently. Here we go, we will rewrite my problem as 2x squared minus 2x, that's these two right here, minus 3x, that's this 3 right here, and plus 3 still equal to 0. All I did was I removed the negative 5 from the middle. This negative 5 is no longer in my problem. I replaced it with the negative 2 and the negative 3. Now I have 4 terms and I am ready to factor using grouping. So let's go ahead and group. The first group, I will be taking out 2x, and that leaves me with x minus 1. The second group, I'll be taking out the 3, which also leaves me with x minus 1, still equal to 0. I'm noticing that x minus 1 match. I will write 1 in the front. Then all the non-matching things, 2x minus 3, still equal to 0. Again, to solve this, we'll take each factor and make each factor equal to 0. My first factor is x minus 1. The second factor is 2x minus 3. X minus 1 equals 0, which means x is positive 1. And 2x minus 3 equals 0, which means my x is positive 3 over 2. Let's look at example number 5. We have x squared minus 64. It's equal to 0. It's a quadratic equation because it has an x squared, but it's not a trinomial. You only have 2 terms. It is a 0 on the right, which is a great thing. That's what we want to have if we want to solve using factoring. Now, this is factorable using the difference of 2 perfect squares. This x squared is x and 64 is 8 and 8. And if that's the case, we can break it down into x minus 8 and x plus 8, and it's still equal to 0. From here on, the same story. We take x minus 8 and x plus 8 and set equal to 0 separately. So from the first one, x is 8, and from the second one, x is negative 8, and you're done. I'm going to show one last example, and that will be my problem number 6. So question number 6, 16 equals x plus 9 times x plus 3. A typical mistake for students to make when they see a problem like this is to just go ahead and set x plus 9 equal to 0 and x plus 3 equal to 0. However, remember, for you to do that, the 16 should not be a 16 and it should be a 0. So before we set anything equal to 0, we need to take this 16 and move it to the other side, the right side in this case, by subtracting it. So I'll be taking this 16 and subtracting it here in the back. Now it's a 0 equals x plus 9, x plus 3 minus 16. At this point, you see that you have no factors to set equal to 0 yet. So what we'll do is we'll distribute and get rid of these parentheses first. So that gives me 0 equals x squared plus 3x plus 9x plus 27, and you still have this minus 16. Now we'll combine like terms. The 2 pairs of like terms are 3x and 9x. They will make me a 12x. And also 27 minus 16, they will make me an 11. I'll bring down this x squared and the 0. What I have on the right side now is actually a trinomial with the leading coefficient of 1. Remember, the leading coefficient is the number next to x squared. So all I have to do is break down this 11 into 2 numbers that multiply to 11, and also find which pair that multiplies to 11 adds up to 12. Well, this is a simple task because 11 is either 11 times 1, or 1 times 11, or it's negative 1 times negative 11. Remember, I want these numbers to add to a positive 12. Well, that's clearly 1 and 11. So I'll bring down my 0. And then I'm ready to write the factored form, x plus 1 times x plus 11. I set each of the factors equal to 0, x plus 1 equals 0, and x plus 11 equals to 0. So the first x is negative 1, and the second x is negative 11. These are your two answers.